The race to colonize Mars has been the greatest catalyst for technological advancement, innovations, and inventions. The world's governments compete, though in the shadows, for who will be the first to bring hope for mankind in space. Various companies, big and small, from all over the world have to fight their way through gravity and space to get to Mars. Amongst them all are the knights in shining armor, SpaceX. Today, we will be carefully considering if the SpaceX Starship can return from Mars without surface refilling. SpaceX and Elon Musk will be launching Starship on its first mission to Mars in the near future. Therefore, it is important for any spacecraft that successfully lands on Mars to consider refilling its spacecraft in order to make a successful return trip back to Earth. Stay tuned and keep watching as we ponder through these questions. There are various approaches to this critical question, but as we know, the Starship is capable of delivering at least 100 tons of payload to the Mars surface. Assuming Starship and Super Heavy were on a mission to the surface of Mars, assuming the Starship was currently operationally delivering the anticipated performance and reliable to perform orbital refueling, let us consider the following. How much fuel is required from the surface of Mars to lower Earth orbit? Delta V is calculated using the Visa equation. Delta V, also known as delta variance, symbolized also as triangle V, used in spacecraft flight dynamics, is a measurement of the impulse per unit of spacecraft mass needed to perform maneuvers such as landing, launching, or in-space maneuvers. Crucially, looking at the information on the image obtained from Reddit, Steve Linton stated, "If you add up the relevant lines, delta V from Mars to Earth-Mars transfer is about 5.92 kilometers per second, assuming they make use of the vacuum Raptor, not planned for the first Starship mission. The Starship will have a capital I and lowercase AP around 380 seconds, so by the rocket equation, delta V equals VC in m0 over mf equals ISP g0 in m0 over mf. Therefore, the mass ratio, mass in Earth transfer versus mass in liftoff from Mars, is roughly E equals 5,910 divided by 380 times 9.82, which is about 0.2. Now, the dry mass of Starship is projected to be 85 tons according to Wikipedia, so about 340 tons of propellant will be needed. So the easiest mission operation in which they land a bunch of Starships, let's say about 4 Starships on Mars carrying 100 tons of propellant, then transfer it all to one of them and fly it back home, while the other 3 will be left on Mars. The ISRU, In Situ Resource Utilization, is another operation that will be considered for a return trip propellant. A report from NASA's Design Reference Architecture (DRA) 5.0 indicates clearly that the use of ISRU for the elevation vehicle propellant is usually considered, usually surface-based or atmospheric-based. This would be made possible through a process called the Sabatier process. In the Sabatier process, making oxygen and methane, which are then super chilled to cryogenic liquids, a small quantity of liquid hydrogen will be needed to fuel the process, and collecting small quantities of carbon dioxide requires digging into a Martian ice cap. However, this process is complicated. It takes lots of infrastructure, requires Martian travel, requires time, and brings IH2 with you. Bringing all the infrastructure and setting it all up will require lots of money, Martian travel, and time on the surface. Now, many of you might be thinking that this is just something that favors only producing elevation propellants, but not the return propellant from Mars, right? Well, the Sabatier reaction on Mars' atmospheric CO2 requires you to bring all of the hydrogens that end up in the methane from Earth. It's light in mass, but difficult to package and transport. However, if gaseous hydrogen could be ascertained from the electrolysis of water also found on Mars, then you would not need to bring all of your hydrogen from Earth. This process could work, but requires time, finance, and infrastructure. We have seen various innovative capabilities of SpaceX, but we cannot conclude that they are presently capable of achieving this until we have scrutinized every possible factor as we move further. In August 2021, Joseph Scotting published an article about SpaceX's ideas on refueling its Starship without needing to return to Earth, or surface refueling. SpaceX was selected amongst other private space companies, securing a $35 billion partnership with NASA for new lunar missions against 2024. According to SpaceX plans for refueling, it will use a multi-vehicle system, including a response Starship that essentially functions as a fuel depot. Once the depot Starship reaches the stable orbit around Earth, SpaceX will then launch 8 refuel rockets which, within 6 months, will dock from the depot Starship and properly refill its tanks one after the other over 6 months. Following total refueling, the Moonlander Starship will launch from Earth and dock with the depot Starship, topping it completely with much of the fuel for its mission. After the operation is complete, it will then fly towards the Moon and dock with NASA's astronauts, although it is unclear if Starship will have enough fuel for the continued operation after leaving the Moon. Elon Musk's plans have been proved controversial in the space transport sector, as Blue Origin founder Jeff Bezos went as far as to criticize Elon Musk's idea as preventing the US from landing on the Moon safely and sustainably. Blue Origin went on to claim that SpaceX got preferential treatment as they were selected for the Artemis program. Elon Musk replied by tweeting that the Starship will need only 8 refuel rocket launches. He also added that even if it were 18 flights with docking, this is not a problem. SpaceX did more than 16 orbital flights in the first half of 2021 and has docked with stations harder than docking with their ships over 20 times. This process is not impossible for Elon Musk to apply during the Starship mission to Mars and its return from Mars. However, it shows that it is not yet possible for Elon Musk and SpaceX Starship to return from Mars without surface refilling, except if they were willing to spend a lot of money, time, and infrastructure and launch toward achieving this. There is no doubt that Elon Musk will be willing to do this. But before we conclude, let us look at some other amazing ideas. We must understand that it is a very difficult task to launch a spacecraft on a mission and also do surface refilling for the rocket to be able to reach its destination. But it is far more difficult to launch a spacecraft that won't be refueled until it reaches its destination. Although this is not an easy task, it's not impossible. We have seen so far one way for a Starship to return to Earth from Mars is for a second Starship to make the same journey from start to finish alongside the first at an enormous expense. Or they can make use of the second process since it takes 3.8 kilometers per second delta V to orbit Mars from the surface, 2.5 kilometers per second to reach an intercept with Earth, and most likely around 7.3 kilometers per second from the Martian surface to the Earth's surface. The fully fueled ITS, Interplanetary Spacecraft, ship weighs 2,400 tons and it lands on Mars weighing around 300 tons, since the exhaust velocity of CH-402 fueled rocket, which is around 3,538 meters per second for the vacuum Raptor engine. Delta V equals 3,538 natural log of 2,400 over 300, or which equals 7.357 kilometers per second. SpaceX plans to do this, but it'll be really difficult. Although, with the account of gravity loss not taken into place, the calculations may not be complete. Elon Musk never talked about propellant tankers orbits Mars, and since the ITS ship has enough delta V to come back to Earth from the Martian surface, this will probably be how Elon Musk and SpaceX might do it. SpaceX plans to generate methane on Mars using the Sabatier reaction using materials on Mars. Once it generates the fuel it needs, it will take off from Mars and, in theory, directly return to Earth. According to an article highlighted by the Aerospace Research Center, interplanetary missions, reduction of launch energy, and the propellant mass fraction is vital to maximizing scientific payloads and resulting outcomes. However, the fuel efficiency of delta V EGA, delta V Earth Gravity Assist maneuvers can be enhanced by using solar electric propulsion, SEP, for the DEM, because a spacecraft must potentially spend some years from launch to Earth re-encounter. Low thrust propulsion such as SEP and solar sailing, which requires long period to produce a desired delta V EGA trajectories. The concept of delta V gravity assist trajectories with hybrid solar electric photonic propulsion could be successful if utilized. With all we might have highlighted so far, we can say SpaceX can make a return flight from Mars without surface refilling in the near future. Do you think SpaceX can afford everything it costs to establish a refueling infrastructure? Which refueling method do you think SpaceX will adopt for its return from Mars? Do you feel SpaceX can return from Mars without refueling in the nearest future? Drop your comments and let us know what you think about all this in the comment section below.